Introduction to carbonyl chemistry. A carbonyl group consists of a carbon atom doubly bonded to an oxygen atom, which gives the possibility of two other groups, which we will call A and B. The carbonyl group itself is flat, which we term planar, and this can be represented showing a wedged bond and a dashed bond. The dashed bond shows that that group is going back into the page, and the wedged bond that it's coming out towards you. And around this carbonyl group we have a bond angle of 120 degrees. So therefore you've got a trigonal planar shape. Lots of different compounds contain the carbonyl group, and many different atoms and groups can occupy the A and B positions. We're going to use the term R for any alkyl group or any aryl group, and the name of the compound will depend on what the R group is. So if we look at aldehydes, we have an R group, and then our C double bond O, and then we have a H as the other atom. With a ketone, on both sides of the carbonyl group are R groups, but these could be different groups or the same group. For a carboxylic acid, again, we have our R group, our carbonyl group, and then the other group is an OH. For an ester, again, here's our R group, then we have our carbonyl group, then we have an oxygen, and then we have another R group. Again, it could be the same or it could be different. For an acid chloride, our R group, our carbonyl group, and then a chlorine atom. An amide has an R group, a carbonyl group, and then an NH2, then an NH2, and then an acid anhydride has an R group, carbonyl group, another oxygen, another carbonyl, and then another R group, and then another R group, and then another R group. Remember that R can stand for alkyl or aryl. So let's look at naming a few of these compounds. First we'll look at some simple aldehydes. Okay, so this is an aldehyde with 1, 2, 3, 4 carbons, so that's named as butanal. Similarly, if we just had the 1 carbon, the systematic name for that would be methanal, although it does have a common name as well as formaldehyde. And if we look at one with a benzene ring, this has the name benzaldehyde. Having a look at some simple ketones, our carbonyl group. This is the simplest ketone you can have, and this is propanone. You can then move on to butanone. After you have had butanone though, you are going to have to start using numbers to show the position of the carbonyl group. So if we look at one with 5 carbons, this is the 1 position, this is the 2 position. So this is pent and 2O. Okay, carboxylic acids, the ending is oic acid. So the simplest one possible here is C double bond O, H, H. This is methanoic acid. And ethanoic acid with 2 carbons. Esters are a little bit more complicated, and we'll spend a little bit more time on that when we look at esters themselves. Okay, so this one here, this part with the carbonyl group in it has got 2 carbons, and this is a methyl group. This is named as methyl. This is named as methyl ethanoate. But we'll look at more of those examples later. Having a look at acid chlorides. The most common one you'll come across in your syllabus has got 2 carbons, and we call that ethanoyl chloride. And let's do one with a benzene ring. This is benzoyl chloride. And amides, put our amide group in here, C double bond O and NH2, CH3. This one would be ethanamide. We'll look at one with a substitution on the amine group. So we have a methyl group here. So the naming stem is 1, 2, 3 carbon atoms, which gives us propanamide, but we have to show this methyl group. The methyl group is on the nitrogen atom, not anywhere else in the chain, so that needs to be indicated, and we do that by writing N-methyl propanamide. Okay, for acid anhydrides there is actually only one that you'll have to come across, and that's a symmetrical anhydride, and it's one that has 2 carbons. For acid anhydrides there's only one that you would have to come across, and that is one with 2 carbons on either side. And this one is called ethanoic anhydride. So I'm just going to put some structures on here for you to have a go at naming yourself. We'll do A, So looking at how we name A, we have to find our longest chain, and our longest chain is 1, 2, 3, 4, 5. So it's going to have a pentane naming stem. So if you look at the functional groups we've got in there, we've got a ketone. It's going to have pent in there somewhere. It's going to have something on. We've also got an alcohol. Now remember, we can do that with as a suffix as ol, or we can use it as a prefix hydroxy, and we have a suffix already in the ketone, so we're going to have to use hydroxy. And we also have bromo. We're going to also have to indicate, because we've got 5 carbons, the position of the one, and if you're going to set the ketone as being priority, then you're going to say that the ketone is in the 2 position, which gives us, putting everything into alphabetical order as it should do, 4 bromo, 4 hydroxy, pentan, 2 one. B, we've got 1, 2, 3 carbons, so we're going to have a prop. It's an amide, so there's going to be amide in there, and there's also going to be bromo. We're going to put the amide group as being the priority at the beginning of the chain, so therefore the position of the bromine is going to be relative to that, so that's going to be in the 2 position. So you're going to have 2 bromo, propanamide. We haven't, however, dealt with these methyl groups here. There's 2 methyl groups on the nitrogen, so we're going to have dimethyl, and we're going to have to say that it's on the nitrogen, so we're going to have N, dimethyl. 2 bromopropanoamide, and then we've got to decide on an order for this, and if we're going to go for alphabetical, then this N-methyl needs to go in the middle here. C is an ester. The part that includes the carbonyl also has a benzene ring, so that's going to be benzoate. The part attached to the oxygen is a methyl, so it's going to be methyl benzoate. It's going to be methyl benzoate. And then D is a carboxylic acid down here, and it also includes a benzene ring. We're going to have to put the carboxylic acid as being a priority group at position 1, 1, 2, 3, 4. So we're going to have 4-chlorobenzoic acid.